Hello. What's up? Um, I think we're good. Not much to report. Before we stream, how do you come up with a topic to get things going or whatever? I don't know. I got a new desk. This desk I'm using right now, I can't really show it off, but it's pretty nice. It's a lot thicker than my old desk. You kind of see the old desk right here. Part of it, at least. I don't know what to do with it. Um, I mean, I'll just hold on to it for now, but you don't really need it when I got this bigger, better one, and it's adjustable. Well, the other one was adjustable, but now I can adjust it if I ever want to, like, stand. It's got dual motors. This is pretty cool. And the weight that you can put on it is much higher. So it's a lot more stable. But it was not cheap. I think it'll be worth it. Like, this desk should last me for a very long time. Um, but it wasn't very easy to put together. Well, it kind of was, but the instructions weren't very clear. And I think that's because this model of desk or something, you can get different configurations, and they try to make the instructions in such a way that it'll cover all bases. So there might be stuff in the instructions that don't pertain to your, like, uh, in your case, but it's hard to know, like, is that my case, or do I not have those parts, or what am I missing? Like, on the bottom of the board here on the tabletop, it just felt like there were holes missing. And there's a piece, like, you can kind of see over here that on the countertop that I just could not figure out how to put on, and it's for cable management. So I said, well, I don't really have that many cables. Um, I can, just leave it off, and that's what I did. But yeah, pretty happy with it. I was due for, well, I haven't had that other desk for a very long time, but it always just felt like very flimsy, and like it's two pieces of wood. The desk here is two pieces of wood that just screw together, and then you have this weird like gap in the middle of the table, and it just felt like it wasn't very sturdy. This one is all just one piece, so that's nice, and it's a lot thicker, and yeah, that's my story. Uh, I think if you spend a lot of time at your desk or on your computer or whatever, you have to have good tools. Um, and hopefully, if you have good tools and you have your workspace set up how you want it, it's worth investing in, and you have better productivity for it, is the idea. But we'll see. We'll see if it really matters. Um, Now I gotta figure out how I want to arrange the room, because I'm not really happy with where the desk is sitting at the moment. But the internet comes in at this corner of the room here, and the cables aren't very long, so I kind of have a limited space to work with. It has to be kind of like in this corner of the room here. But we'll see what I can come up with. I might just shift it this way a little bit. Because right now there's a little bit of a glare with the window on this side. But as the sun goes down, or comes across the building over here, well, I guess it's coming from this way. So this way is north, so maybe it's coming this way. But I'd expect that as the sun goes up and over the like over the midpoint or something, and goes on this side of the house, or on this side of the apartment, it'll be better. I hope. Yeah. So today we're doing 3D sprites. I think that's a link. That's not a link, but the second one is. So I have this example here that is currently on the website. Shift this over a little bit. Yeah. And it uses this image. So the idea on this is that the sprite is always facing the camera. The sprite is the picture here. And it's always facing the camera, so it's a flat plane that faces the camera no matter where the camera is at. It's always going to be facing the camera. But depending on like the rotation of that sprite, you index into the texture differently. So this texture here, we can actually look at it. It's pretty much this. Or let's see if I can do this. Let's go to this project. And it's in source, assets. Do I have... I think I have an alias for this. Where is it? Yeah, so this is the actual image that's being loaded at runtime and stuff. And it's kind of like an atlas. So this is a one whole texture here, and then what you're supposed to do is index into each, or you have your UVs, and then you, whenever you sample from that texture, you're only going to sample one of these sprites, depending on what the rotation is of that plane. So if the boo is supposed to be, you know, facing away from the camera. Hello, how are you? If the boo is supposed to be facing away from the camera, then you're going to load that back-facing sprite, one of these over here. And, you know, as you rotate the boo around, you're going to show different sprites depending on the rotation. But the problem with this is that this image isn't so great. Like, it's not a power of 2, and it's not, like, I think the height of it is a power of 2, but this has like 18 different sprites in it. And you can tell sometimes when it samples from the texture, you get a little bit of artifacting. Like right here, when it comes back around, look where the pointer is at, and you'll see like there's a little bit of a blip of like white that comes through, and that's because it's picking up part of the texture. Like maybe it's this one here. It's picking up one, like a little bit of a sliver of the one next to it. And that's because we're dealing with floating point numbers. It's kind of like right here, you can barely see it when it comes back around. Yeah, it like blips. It's like a little bit of white that comes through. And that's because when you sample from the texture, you're working with like floating point numbers. And because, you know, floating point numbers can't, you know, really... we only have a limited of space to work with in our floating point numbers. They may not be accurate. So the arithmetic with them, like multiplying, dividing, and adding and all this, can introduce like a little bit of error into the calculation. And I think that's what's happening here, and it's because the, like our sampling isn't being correctly calculated. Well, it is like it's doing its best it can. Like you might get better results if you had like we're using like a double or something rather than a float. You know, you had more bits to work with to represent your numbers and stuff. But I kind of just want to avoid all that altogether. And what we're going to do instead is actually create our own version of this using three.js, and the process is kind of detailed here in this article on the three.js website. And in this example, what they do is they render a tree to a separate render target, and then they use that render target's texture as the map on a sprite. So let me see if I can find where that's happening. Can I make this big? Yeah. Can I find inside of here? Oh, look at that. Yeah, so they have this make sprite texture. In here, well, you know, they make a texture out of that canvas. It's going to be a canvas texture, which takes in an HTML canvas that you've written stuff to. What you can do is set the render target to that canvas, canvas, and then you create a texture out of it, or actually the render target will just give you the texture to use. So you don't even have to make a canvas texture actually, but we'll get there. And then you make a sprite out of it. So you make this sprite thingy, and you know, the sprite has a sprite material, and part of that sprite material has a map. And that map is going to be the actual texture that you've created. So the idea is you render a scene to a texture, use that texture as the map for a sprite. So what we're going to do is have some scene. Maybe our scene is like a box or something. I don't know. I haven't come up with a good thing to put in the scene. But we're going to render a texture. So we're going to have the camera here. Let's say it's like this. And we're going to have a texture. And what we're going to do is we're going to render whatever the camera sees here, like it's... let's actually draw the frustum. So it's something like this. This is the backside. And this is that top right side. So this is the camera looking at the object. We're going to render what the camera sees into this texture, and then we're going to rotate the camera around the texture. You know, maybe by like, you know, it'll look straight on. It'll look like, you know, camera will be like, this is like a top-down view. This is our scene here. This is the box here, and then our camera here, and maybe we'll rotate it around. And get different shots of the scene or whatever, and we'll render those into a target. And then, you know, maybe we've got like 8 different renders or something. You know, this is just going to be laid out in a line or something, and that way we can control the width and height of this texture. We can make it a power of 2, and powers of 2 are always like something that you can easily represent with like floating point numbers. It's when you have to do weird things, like I think in this example here, the texture that's being used, every sprite I think is 38 units. Let me see. I don't know, it's not like a good round number that you would want. Like usually you want to work with, you know, powers of 2 because we're working with computers here. But this image, let me see if I can do like, yeah, it's 864 by 36. So the 36 isn't a power of 2, it feels like it is, but it's a square number. So you kind of want this to be 32, but if you take the original image with this one here, even these sprites here aren't very well like segmented. Like some of these are very short. Like this one is, the width of this one here is not as much as the width of this one, for example. So whoever did this sprite sheet or whatever just stuck them all together, made sure they fit, and then called it good. But we can do better than that, and we can actually do something where we're not using somebody else's assets. So that's the idea. And you can tell here that you don't, if your, you know, like entity, I guess, is symmetric, you don't have to put in all the sprites. You know, this Boo here has the same color on his right side as he does on his left side, so you can save some space by just flipping that texture around, and this is, you know, something they had to do a lot on the Nintendo 64, I guess. I don't know much about all that, but I'm assuming they did it to save space, and probably flipping a texture was probably something that you could easily do. So why make, you know, big textures when you can just get away with like little shortcuts like that? And I don't know if we'll do that on stream, but that's something that we can do as well. Assuming that the entity or whatever, the material is going to be like symmetric on some sides or something like that. So that's the idea. I think I explained it pretty well. And I haven't really prepared any of this, so what I wanted to do today instead was something a lot more advanced, but still doing research on it. I don't know if I'll go into the details about it, but I did kind of last stream, at the end of last stream. But when you get into very complex and complicated stuff in 3D, you get into like academic papers, and they are very difficult to convert to code, or you almost have to be not like necessarily an expert in that field, but you really have to be well acquainted with a lot of the topics in that field. And the field is, I wanted to do something on like what is it called? Tetrahedralization? So in three.js, these are surface meshes, which means that you only have data about the surface, and the idea is that, you know, you don't really care what's inside of the mesh because you're not going to be seeing inside the mesh most of the time. If you know to see inside of it, then you're going to be doing some other kind of processing, or you know, maybe you'll have a mesh or something for the insides, or you'll have a texture or something like that. If you were to like slice a cube in half or something like that. So the stream that I want to do is creating a surface mesh tetrahedralization, but this is a pretty advanced topic, and I haven't found something that I feel comfortable with that I could do a stream on yet. So maybe we'll get there, but I gotta do a lot more research. And where I want to go with this is sampling inside of a volume of like a mesh or something. And the reason why you had to tetrahedralize it is because you would get tetrahedrals out of this in the end, and then you could sample from that set of tetrahedrons. Like a tetrahedron, I'll show you real quick. You know, you'd almost, well, it's the 3D triangulation of the mesh, and then you could sample from the tetrahedron to get kind of an approximation of like samples inside of some volume that is described by your mesh. So very similar to, I think it's mesh surface sampler here. So if you're interested in this, it's kind of like the 3D case of this. I'll show you, I'll link the actual example. I know where to get it. But, you know, I was thinking like there's probably a reason why this isn't in the, there's not an example for this in the three.js docs, or at least examples page or list or whatever, because it's pretty complicated. But anyway, back to the topic today. So the first step I think I want to do is make like a scene that we can work with. And I don't have, I mean, I've got some GLTFs locally. Like we could use some of these. I might use the shell, it'd be easy to use. I mean, I might do that just, well, I mean, it might be best to have something that we know, that we kind of can predict the results of. So using like a cube that has mesh normal material on it would be easy to use. It wouldn't be very exciting. And, you know, if you want to make something exciting, it's nice to have actual, like actual GLTF to work with. So maybe we'll use this. This is a shell. I'll load it up real quick. So I'm just going to comment out some of this code because I think it'll be relevant later on. I'm going to keep this, and that's about it. But all of this I'm going to get rid of. And then we'll put in the parts that we still need, like the scene and a camera. So doing this, I wonder in this example, this is going to kind of be the guide. Oh, I lost it. Let me pull it back up. Well, this will get us here. Maybe not. Maybe it won't. I just want the three.js web page. Billboarding and sprites. Let's see, where did they do that? Yeah, right here. So use a perspective camera. So I guess we'll do that too. I think we might get better results with using an orthographic camera, but I'll just use a perspective one for now. What's all this? Let's clean this up too. That's not something we'll have to deal with later. Okay, let's look at the scene, and we shouldn't have anything in there, but let's put a mesh in the scene. Actually, let's not do that. Let's put the shell in the scene. Okay, it's loaded. We need a loader for this. Oh, I already have this module, so all of this we don't need right now. Don't need that. Don't need that. These we don't need, but we do need a loader. And then with that loader, we don't need this either. Pass it into this, and this is a promise. So here we'll get out the GLTF, and we'll just add it to the scene. Oh yeah, let's call this GLTF loader. It might have different loaders. Like an environment loader, we might load an environment in a moment. Okay, let's see. I know this is a very small object, so you can kind of see it there, but we don't have lighting, so let's add an environment. Room environment. And then, I don't remember how to use this thing exactly, but I can steal it from some other code. Do I have it anywhere else? Okay, we have it here. Oh yeah, it needs to be something that we dispose of later on. Okay, how do we use this? Let me just get some of this boilerplate out of the way. PM. And we also have to clean this thingy up. So let's do that down here. Let's see. Oh, need to push this down here because creating that PMREM thingy requires the renderer to be like ready to go, and it's an asynchronous renderer whenever you use 3 web GPU. So you have to wait for this promise to be fulfilled, and here it is. Camera's not very well positioned, but we can fix that. So here I think I've got... Oh, we can just do this. Okay, so here we go. This will be pretty much our very first image that we're gonna put into that like texture map or that atlas. But how do we do that? We need to make a render target, and we need to render to it. So that's kind of this step here. This camera, I'm going to like like it says here, the target will be square. So the field of view, this first argument, field of view, I'm not going to mess around with. The aspect, the near, and the far, I'm not going to mess around with. We don't need to account for if the here where we set the aspect ratio, this would be, you know, in this case, it's a lot more wide. The canvas itself is wider than it is tall. So to adjust for that, you would adjust the camera's aspect ratio. We don't need to do that. And you can see immediately when I do this, we'll get kind of like a stretched out image. Well, it's hard to tell, but if we take the... Hold on. I think it's because the aspect ratio here is 1:1. Because at larger sizes, let's see, I have an aspect ratio square here. If we make this very big, we should get some kind of stretching. I'm not going to worry about that. The idea is that because we're rendering to a square, the aspect ratio should be 1, right? So we don't need to put this in an if. All right. Oh, that's the wrong file. What the heck? Nobody told me I was working in the wrong file. I was like, why aren't we seeing anything? How do I get back to where we were? do this. Restore. This is components, examples, halftone. Alright. What I wanted to do was edit that billboarding. This file, this is the one we need to edit. So if we don't do this, yeah, there we go. That's what I expected. So we will need this when we actually render. We'll need two cameras. One that we're rendering the render target, and then one where we're actually rendering the actual scene. So the scene was to give you the idea of what everything was. If I go to like the actually deployed website, where is it? So this is the actual scene. The render target in this case is the Boo like image. Render target, and we'll take its texture. So we'll have two cameras, one for the render target texture and one for the actual scene. All right. So right now, this camera positioning thing is just kind of like hard-coded. We can make this better by actually running this function here, which will put the camera right where it needs to be. So this is something that will work no matter what kind of object we're dealing with, or what kind of like mesh that we're dealing with. I don't know the actual math behind this. It might be worth looking into, but it's just something that you can just say, yep, it works. So that's what we're going to do in this case. And this is JavaScript, so we don't really know the types of these, but we can kind of infer them ourselves. But you know, it makes this bounding box around the object, the shell in this case, gets the center and the size, and frames the camera around those kind of parameters. So this will be pretty easy to copy. So let's just call this like frame scene. I'll just stub this out for a second. But once the GLTF is loaded, then we need to take the bounding box. So we can do that here. We can say box.set from, oh, object points. We're gonna do object. And let's look at the actual bounding box of the object. I'm thinking like, you know, we have this box out here, but we really don't need it anywhere else because it's sending the properties of this box, or these are, you know, methods that will return different objects, size and center. This is probably a vector 3 and a position here, and then passing that along to the frame area thing. So we could probably just put the box in here, which means we can do this. This will return the box itself. And then we can say box size is box.getSize. And this is the target. So it will put that in the target. Need to bring this in too. And in the center, So this fudge thing, that's like, you don't want to put the camera like right in the box. You want a little bit of a buffer on the sides and stuff so that you're not like directly focused on the box. Let's actually set this to 1, show you what I mean. You want this number to be a little bit more than 1, I think. We're going to see in a moment. But if we set it to 1, it's being multiplied here. We're just going to set it to 1 so that we just get this number out here. And we'll see what happens. So this is taking the maximum dimension. So they just spread it into math.max, and then whatever that results in, multiply it by the fudge, which is the weirdest name to give a variable. And then they're calling frame, our case is frame scene, they're passing in the size twice, the center, and then the camera. What is this? Camera. So what is this? This is a number, vector 3, and the camera. And the camera is a perspective camera. So we got everything we need. Now in the frame scene thingy here, we'll do stuff with the camera. Let's just copy this because there's no sense in typing it out. It'll fit on screen. I think these could probably get better variable names, but I don't know their exact, like, I don't know what to name them, so we'll just leave them as they are. Math.utils comes from there. This is a function call. I usually just like to use the constant version of it. And we can do 0.5 times this. I like my constants out front like they do in math. And we don't even have to wrap this in parentheses. Probably need that. I'll leave that alone for now. Well, no, I'll take it out. Yeah, so this will position the camera where it needs to be. It'll call update matrix so that the camera's properties are then updated on the GPU. Let's see what this gets us. So if we take the fudge value and increase it, well, that's way too much, I guess. Oh, what's happening? Are we having errors? Make sure they're rendering. Yeah. Let me take a look at the camera position here. Might need to call look at. Yeah, so it's like pretty much 0, 0, and then along the Z by a very small amount. Oh, we need to do this up here. Get rid of this. So it's almost like what I had before, 0.25, but I'm not sure why I don't see anything. it might be this. Oops. Oh, this is still an if. That is tricky. There. So this fudge amount, yeah, it is kind of like adding a buffer to the sides. If you just set it to 1, it should focus it entire, like, you know, it's right on the edge. Just return, yeah. Oh, you can't add Z, can you? I guess you just have to do it like that. I don't know, let's put in, let me see what the position is at the moment. So like 0.25 along the Z. And if we add a little bit more here, 0.27 give or take. See, it's weird because on this side of the shell here, it kind of looks like it's clipped a little bit, but I don't think it is. I mean, if we rotate the scene here, rotate Y by like a really small amount. Okay, yeah, then let's go like 1 over like 16. Yeah, I think it's just part of the model. Let me see what they look like on the other examples. Yeah, right here. It's just got like a cut in the shell itself, I think. Oops. What does this do? A little bit of a detour, but let's see. Max, dot max. Oh, okay. So it's kind of like, if this vector x, y, or z value is less than the given vectors Oh, this is on a vector. So you're taking the max of two vectors. Okay, that's not what we want. We just want the maximum, like, component. Which I guess you gotta do this way. But converting this to an array doesn't feel right. I mean, it'll work, but I don't like this. I'd rather just say... I'd rather just do it this way. That should be the same result. Okay, so we have the camera framed around this thing just how we want it. And it doesn't matter what the object is, it will frame the camera, or frame the scene. I got streamer nose. Your nose is really itchy. Let's do this. Okay, now we need to make a render target. Because here, the render target, like when you make this render, you give it the canvas, and that will be the default like render target. But you can actually render to other things. And what we're going to render to is, well, we're going to make a render target. That's going to be what we're going to render to. So let's make one of those. And there will probably be a better way to do this in like TSL and stuff. Let me see if there's a quick example. Examples, let's jump to web GPU. Let's do render target. WebGL advanced, GPU, render targets, multiple render targets, read back. It's probably where you're using multiple render targets to output color and normal separate buffers. Yeah, render to texture is pretty much what we want. Okay, so they're just using render target. So I guess we'll do the same thing. And I wonder in my render target like example, if I do the same thing, yeah, right here. What the heck? Stupid key maps. What was that example called? Wasn't there an error down here? Yeah, there is. What does it want here? Can I just make a texture that's nothing? Because it wants me to pass in stuff into this. Requires 9 things. Yeah, I don't think so. Because you should be able to just do new texture here and not have to worry about passing in the parameters. Yeah, so there's something wrong with this. And maybe this needs to be optional, which in that case, we do this. Ah, look at that. I hate this error. This is like the bane of my, one of the banes of my programmer existence, or 3J, or like TypeScript existence. But even here, like, we're not passing in anything, so it should be fine to not pass in that second argument. Let me take a look at what the texture accepts when you make a new one. I don't know, I'll deal with this later. It'll probably be some little hacky thing. Don't need all this. Okay, we don't have this imported, so let's bring that in. So I believe, so my concern here is that when you render to this thing, can you set the, yeah, I think what you have to do is this, because what I want to do is render to only a part of the texture. Otherwise, we're going to have to stitch all these textures together. And this, I don't know if you can do that. But we'll give it a shot. So what are we going to render? Let's just make this. Let's just render one thing to see if we can get that working. And then we'll worry about extending it to more than one. I wanted that example. So their texture size here makes, let me see. Tree sprite info. They make sprite texture 64, so they're making theirs 64 units, which sounds like a good number. Let's do that, I guess. So this will be size by size. What are our options here? Count, I think that's if you wanted to render let's see, render target. Oh my gosh. Minus the number of color attachments must be at least one. But how do you use this? I think we should just keep it simple for now. If we don't pass this in, it'll be 1. And then in their example, I should have made a separate tab for that. Do they set properties of that render target, like the min mag levels? No. Okay, well then we'll just leave it like it is. This is all things that we'll probably play around with once it's like actually working. Okay, so when we go to render this, actually, let's do this. We'll make a sprite. And the sprite import. And it needs a material, so we'll call this sprite material. The map here will be the render target texture. And then we'll do scene.add sprite. And probably want separate scenes for this. But if this is the only thing we're rendering, then you can actually just render the sprite. You don't have to put it in a scene unless you needed like environment mapping and lighting and stuff. Which we actually do because our GLTF has like standard materials on it, so we will have to put this in a scene. If you were using like that box, remember that like normal material on that box, you wouldn't have to do that because it doesn't have any lighting. It's just taking the normal and using that as the color. But for our shell, we actually do need to put it in a scene. So we got that. But these need to be separate scenes. So let's call this main scene. And then in the end, we'll render the main scene. And this camera, we'll actually make a main camera too. And I'm going to move it so that it's kind of like along the 111 axis. Maybe like 1 unit. And then make sure that when you do this, you call main camera.lookAt main scene.position. Otherwise, you'll move your camera, but it won't be, this is the center. You'll move your camera, like, initially it's at the center. You moved it some amount, but it's not pointing at the center anymore, so you need to look at the scene position, or like the center of the scene. And here, when we do the resize, this is where we'll actually adjust the main camera again. So the aspect is width of the canvas divided by its height. And then we'll call set aspect ratio or camera aspect. Pass in the camera and the aspect. Okay, but there's nothing on this render target. So just to show you, we should see should be facing the camera. I should see something. Oh, this needs to be main camera. And this needs to be main camera. This is the problem when you have more than one camera. But I'd expect to see our sprite, and we don't. So something's broken again. And now I gotta figure out what's broken. So here we make the main scene. Let's just add in and this should really be create exposed. And I think this too. Or maybe not. Okay, where is our mesh? We have an error? Okay, there it is. Okay. Let's add in the sprite and get rid of that mesh. That was just for debugging it. Yeah, there we go. So we don't have this map anymore, but that's showing that like we see the sprite. Now we need to actually see its or set its like texture. And there's nothing rendered to that texture yet. That's where we do down here. We'll actually render. Well, we don't need to do it in the loop. We only really need to do it one time. So like before we start our main loop, in here where we render every frame, we need to render the, how do we word this? You need to capture all of the like pictures, like, you know, your camera needs to take a snapshot of everything about that render texture, right? The sprites, it needs to get all of the like snapshots of the sprite, put that on the render target texture, and then you can read from that texture in the main loop. So you don't need to do this except for one time in the beginning. You don't need to do it every frame because it won't change. You would if you wanted to get different snapshots and replace data in that texture. You know, you'd render to that texture some different things, but you only need to do that once because in this case it will never change. You know, imagine these sprites here, they don't change. You know, you're just reading from that texture. So rather than doing it, you know, you can imagine we have like this loop that we run, and that's kind of like our runtime in a way. And the things that you do before the loop, before your main render loop, is kind of like static in a sense. That it's kind of like almost like a compile. Like it's not really compile time because this is all runtime because we're in JavaScript, but it's almost like a pre-render loop kind of step. And that's where we're gonna write data into that texture. But in order to do that, you actually need to make sure that this here has this initialized, what what is it called? Render dot. How's it going? It says you're not a first time chatter, so you've been in here before. Hopefully I'm explaining things correctly. It's hard to, oh, what's up, Wolf? It's been a long time. I didn't know you were still around. Why'd you change your name again? I missed you, Wolf. It's good to see you, though. They're okay. Like, I don't really work in the industry anymore, which is, I guess, I don't make as much money, but it's a little bit more, calm, I guess. But I don't know if I want to go back into the industry, like, not to get on that topic that everybody gets on, but I just don't want to deal with AI. So that's kind of like uh, something I'm trying to avoid. I don't know, we'll see. The idea now is to get into grad school, but I've been kind of lazy. So I work at a grocery store, and it's super easy work, but just it doesn't really pay that well. So um, I mean, it is what it is, and eventually it'll be like, you know what, I gotta do something more. I gotta lock in and actually like be productive in a sense that like I'm not like stagnant and working a dead end job and all that stuff. So it'll happen. Either I'm going to get a job that's a little bit more fulfilling, maybe not programming or coding or computer science, but something that has more meaning to it, or I'll go into what is this? Auto mod? I didn't know I had an auto mod. I don't know what that was. Like, what are all these like things that Twitch just gives you? I mean, I could make like an application. Yeah, I guess I need to turn that off or set its like strictness to be less. You know what I mean? Like, be not be so strict on things. I had to like mess around with Nightbot too because it was too strict in the beginning. Yeah, I mean, it would be cool. That's what I want to go to grad school to do is something in computer graphics. Um, and that's why I moved like where I am now to get to like grad school. Um, but the process is it's kind of like it's not difficult, but there's a lot of work involved. Um, and you got to pick like a topic that you want to study and all this. So I don't know exactly what I want to do. Seems like it'll be a very important decision, so I want to get it right. But I don't know if you can like, uh, like when you're an undergrad, you can kind of like switch and like kind of find your way or whatever. It feels like when you do grad school, you're kind of like set on one path and you can't really deviate too much. I've been working with it for a while, and I feel like I know it pretty well. But there are still things that I'm like, uh, a lot of it is like when you get into like shader code, for example, and the low level stuff. Like when you start actually getting into like the actual like GL calls and stuff like that, because so much of it is what is it called? Not obfuscated. What's the other word? Like abstracted. So much of it is abstracted, but when you have to get into those low level like procedural calls and stuff, that's where it gets really difficult. And that's a lot of the like papers that you find and other resources that you find are just doing this in like OpenGL and stuff. Yeah. Yeah, that's what a lot of people do. They find an example that they like and they just grab the source code. It works pretty well. You know, nothing wrong with that until you have to fix it. You have to figure out what went wrong or whatever. But yeah, I started streaming again, and I'm trying to keep up with it. So it's kind of hard to find topics. Not hard, but I try to have topics that are interesting. You know, I could just get on there here and just like, uh, you know, goof off or something, but I don't know. I don't think I'm that interesting. I'd have to have something that people want to stick in, you know, stick around for and tune into and stuff. And it's good practice because at the end of the day, like at the end of all this and do the grad school and all that and finish that, I'd like to be a professor. And this is just good practice for explaining topics and stuff. Yeah, every stream, at least one time, every stream I get one of those like free viewers at this website thing. Yeah, I've heard that good at explaining things. I don't think I am, but I'll get better. Yeah, it's just practice. Oh, look at my arms. Oh, they look big on camera. Look at this. All right, thanks for lurking and aren't they big though? Oh, yeah. Yeah, my arms are big, but so is my stomach. It's all that fast food and all that sugar and yeah. Um, what were we doing? Yeah, thanks for saying hello and chatting. Um, have a good lunch. Let me know what you make if you make anything interesting. I will probably go get a burrito, but we'll see. What was I doing? Yeah, so we need to make sure this is initialized before we uh, try to render with it. So it has this Boolean property, which will tell you if it's been initialized or not. Because this is an asynchronous thing. This is, remember, like, this is a web GPU thing, and um, if you ever look at like web GPU stuff that's outside of three.js, you know that, or you'll find that the render has to be initialized, and that happens asynchronously. So there's some promise or something somewhere in the code that you have to wait for before you can actually render. And I think you can call init, is it? Yeah, so you can init and then do your stuff in this .then callback. And if you ever look at the source code of three.js, when you call set animation loop, it will actually do something like this in the loop. So like, this is the code. Before it like sets the animation loop, it'll actually do this part of it for you. So you don't have to do this if you're only ever like going to do like your rendering in an animation loop here. Like you render every frame. You don't have to do that, like wait for the initial, like this is all you need. But in our case, we need to render one thing one time before we go into that render loop. So we'll actually have to await render.init. But because we're in an attachment here, we can't do that. We can't call await. Because you can't make it an asynchronous attachment. You can't put async out here and expect it to work. So we have to do everything in a .then. Yeah. So just to show you here, this type error is pretty complicated, but at the end here it says you can't assign this function that returns this promise here is not assignable to one of these. That's because you can't use asynchronous attachments. So instead you have to do the .then part of it. So you can do renderer init .then, and here's where we'll render to that render target. And it doesn't matter like when this runs, because that texture is already being used when you create that material here. So it'll just be a blank texture until you render something to it. And that's why you see in the thing here, there's an actual box here, but there's nothing on that texture to show. If you do color white, oh, this is a function call here. Well, yeah, well, you can understand. Like if we, I guess the color overwrites the map part of it here. I don't know if it's multiplied with the map or something internally, but I think you get the idea. So we are showing it, we just don't have anything rendered to that texture yet. So here what we'll do is we'll do render.render, but before you call render here, you need to set the render target. So you can do that like this. You'll call set render target, I think. Yeah. And where do you want to render to? That's where we'll pass in our render target, which I think I still call it RT. Active cube face. This is, I guess, if you want to render to a cube render target, but we're not. That should be all we need. And then we'll render the scene, which is the like render target scene with the render target camera. I think we just call that camera. So that will do the job, but after we do that, we need to make sure that we set the target back to what it was before. And you can do that by setting this to null, or a better thing to do is to get the last render target before you set it. Oops, get render target. And then you set it back to that last render target. And then you might need to call .needs update. Let's see if they do that. Let's see. Yeah, so here, where do they call the render? Let's see if we need to call .needs update. See, this I'd expect it to work. So, how do we debug this? This is a tricky one here. It might be because of that environment map thing. So maybe here we need to wait for it and then do the actual stuff there. So here we can call this, and then I'll move this down here. Into this block. So this is saying when that PMREM texture is ready. And we set the environment map. Render once. Wonder if I can do this. I have to import texture. Oops. Any errors? Aha, we do have an error. So yeah, this is where it gets tricky. Like I was saying, like sometimes you get into the actual, like you get an error from the actual GL stuff, and you can tell this isn't like a three.js error. This is like you're doing something out of order or something you're not supposed to be doing. Um, so how do you debug this? it's, that's the tricky part. Alright, let me take a quick break. I can get some tea, and then we'll tackle this. So I'll be right back. Okay, I got my tea, but I drank it all. Sweet tea is good. And I don't care what anybody says. It's better than Coke, and it's better than Sprite. It's better than coffee. I don't know if it's better than water, though. Water is pretty good. But I would have to rank water first and then tea second. Sweet tea. Let's see. Does this take us anywhere? Kind of. So I want to see if we don't do this. Do we get an error? No. So it's something to do with this part of it. Okay, what about this? No. What about this? Uh-huh. Oh, this is weird. I mean, it could do this in the loop and just say if we haven't written to the texture or the render target, then skip that or do it. And if we have, then just skip it. Um, I don't know if I like that. I don't like that approach. Because then we're just running that if check every loop for no reason. Well, the only one that'll matter is the first iteration. But it's something to do with this here. And probably because we're using that texture and writing to it in the same same synchronization scope, according to this. So I mean, I could return a promise from here, and then do the loop part of it after this resolves. That would probably work. So here we'll do dot then. Hold on. What's my error? Yeah. So this cleanup function, it will set the environment. So part of this function, or part of this callback, this promise callback, is that it sets the environment here. And anytime you kind of like modify something, you probably want to undo what you did in the beginning. So when the user of this is just a good habit to get into. If you have some kind of cleanup or you did some kind of modification to something, and then those resources are like no longer needed, you did your job and it's time for you to pack up and go home. Well, you probably should put things back to the way they were before you got there. Kind of like that, leave the campsite clean mentality or whatever, right? That they say. Like, well, there's a phrase or something for it where you should, don't leave the campsite a mess. Clean it up, put it back to how it was, and let the next person. It's kind of like, be kind, rewind, or something like that, right? So that's kind of the idea here. This cleanup function we'll call eventually, but we'll just pass it along to this dot then, to the next promise callback. And in this one here, this is where we'll do the renderer loop. So we can actually come down here. We'll just steal all of that, and we'll just return this. But we're not calling cleanup in here. What's the problem? Well, this is a lot of promise juggling, but let's see what happens. So when we return this promise, we need to somehow get this cleanup function out of here. So probably then this promise here doesn't return anything. So in this part here, we can just probably return cleanup. And then if we take a look at this, let's see. Cleanup is void. Okay, well. Oh, we returned it here. So... And that's our callback. Where do I put this cleanup thing? Oh yeah, you can't return something from this. So we'll do this. We'll dot thin it. Do we need to dot thin this? This is where, this is where it's tough because this would be easier with await stuff. We need to somehow get this cleanup to be returned from this dot thin. I mean, you could do this. This would be the dumb, like the dumb easy way to do it. Is just to do this. But then you have this promise that you're doing inside of this dot then. I guess another thing you could do is separate this part of it. So move this out here. This is the promise that sets the environment. Let's comment this out for now. Oh, not all of it, just that. So after that promise completes, yeah, okay, I see what we can do. We'll do PM rem promise dot then. Here we made sure that we set the environment properly. Now we can do the renderer part of it. So that's this thing here we'll need. Don't need this quite yet, but we will need to dispose of the renderer properly eventually. Okay, no errors, that's good. So this is setting the render target from this promise. And then setting it back to the canvas. Now once this completes, that's where we can actually start the loop. So the render loop is here. Right here. We'll just steal that, put it down here. Like that. And then that's where we'll call renderer.render. When we get here, the render target should be fixed. Well, not fixed, but set to the default. And then here we are rendering the main scene and the main camera. Or main scene with the main camera. Okay, so no errors, but we don't see anything. I wonder if I can write something into this render target to make sure that it's got data inside of it. Okay, so let me step through this. So we make the renderer, we wait for it to be initialized. Once it's initialized, we can set the environment. Store that in a promise. Once that promise is completed or fulfilled or whatever, then we render to the render target. Once we do that, then we can render the main scene. And on cleanup, we say to reference to that environment promise, which has the cleanup in it. We clean it up, we dispose of the generator, and then we dispose of the renderer once this promise completes. And disposing of the renderer will set the render loop to null, so we don't have to worry about that. And let me try rendering the scene with the camera again. Okay, and then let me put a mesh in the scene like we did before, just for debugging this. Where's your scene? Oh, let's see, did I not add the shell to the scene? No, I did here. We don't see anything. That is surprising. Okay, let's try this. Okay. Now we see something, but this isn't quite right. So here we added that there. I need to turn my monitors closer so I don't have to keep doing this. I don't know what the problem is here. But I'm not gonna give up. I only get this working at least, and then probably make a second stream for it. So what do we need to do? Let's make sure the sprite is getting drawn again. Down here. Oh, we're not in a loop. What the heck? Where did our loop go? I did not expect that. Yeah, let's return this. If this is the problem, it's gonna be annoying. Yeah, right here. Okay. And then I want the main scene and main camera. Right, looks good. Here, we'll put the texture back. Not the color, just the texture. And here, we'll render to the texture. No, we don't see anything. What the heck? I was so close. Okay, let's do this. In that scene, that like render target scene, let's add new mesh, new box geometry. I don't think it's a problem with the framing and the loading and the function loading and all that. But here we'll do camera dot translate z 5 units. Okay, that's expected. So that's working. Now why isn't it showing the render target? Not sorry, the shell thingy. But you can see that we rendered the... Let me make this a little bit more apparent. Let's take the scene background and we'll set it to... Let me see if I know how to do purple. That's red and green, and let's do this. Oh, we need to make a color out of it. And of course, we need to import color. So we made the... You can see the pink here. Not really purple, but it's pink. So we rendered to that render target, and then if we were to move the camera around, you know, the sprite would always face the camera. But we are rendering to that target before we're using it as a texture in the main scene. It's just not rendering the shell for some reason. And maybe it is. Maybe this is because this isn't a callback and we need to wait for this to happen before we do the render part of it. So I think again here we need to do this part of it in a dot then. Or we can make this, we can await this up here. Yeah, there it is. So the reason why I don't want to do await here is because it will, you know, wait for that promise to finish. It will stop here until that GLTF is loaded, and then it'll continue. And do all of this stuff. But we can do a lot of this stuff before that GLTF is loaded. Like a lot of this is just creating like instances and stuff that we're going to use eventually. So that can be created, you know, it doesn't really matter if the GLTF is loaded or not. It only really matters you know, when we draw that render target. Down here, where we actually render, that's where we need to wait for the GLTF to be loaded, because we don't want to render without it being put in the scene. So we need to wait for it to load, put it in the scene, and then render it. So if we do this, this will return a promise. Abalone promise. And I call this abalone because that's what the original file is called. And it comes from this Kronos, like asset models and stuff from this repo. So somewhere down here is the shell. I think this is alphabetized, so it might be, yeah, this one here. And don't be like me. If you're using these assets, make sure that you provide, like this is the legal part of it. You need to adhere to the licenses of the assets that you use. So I think in my case, I just need to put a link to probably the repo, or I might even be good enough to put like a readme next to this file in the source code or something. Depending on whatever this document says to do with it. But these CC licenses and stuff, Community Commons licenses, are pretty permissive. There's the shell. So that, then that. What does this return? Oh yeah, the cleanup. We're not gonna clean it up here. Well, we couldn't clean it up here though, because that's the only place where we need it. So we don't have to do this. And we'll get the cleanup out here, and then as soon as we render with it, we don't need that PMREM generator anymore, so we can dispose of it. And what was the cleanup doing? Oh yeah, it was setting the environment back to what it was. You don't have to do that in this case because you're not going to be rendering with that scene anymore. But it's just good habit to get into doing that. And that's a really big like issue, not issue, but that's a really big consideration when you're writing these like reactive, what do you call it? Like if you had this in a component and you unmounted that component, you would expect everything to go back to the way it was. So it's important for that, but not really important in our case. But if you're making this like some kind of component or some kind of function or whatever, right, then that would be something you'd probably want to do. But here we can wait for that promise. So this is our PREM promise. This is where we set the scene stuff. The scene needs to wait for the renderer to be, or sorry, the generator here needs to wait for this renderer. So there's a lot of like waiting for things and organizing stuff. This promise, we don't really care about its return, so we can just wait for both of these promises to complete. That's the abalone promise. And both of these promises, this one at least returns cleanup function. This one doesn't return anything, but we need to wait for the work that it does. And there you go. So we got the very first, all of that just to show that little thing. But now what we can do in this part here is, you know, move the camera, like kind of like what I talked about in the beginning. Our scene is like this. This is a top-down view of the scene. And we have the camera here. And this is the first like picture that we took, snapshot that we took, is what we see here. And it's flipped because we need to change the flip Y, which you can do here. Okay, is it true then? Maybe in properties? Oh. Well, there's a way to flip the Y back around. Because it's upside down at the moment. But that's probably alright. Good enough for now. But like I was saying, you can now move the camera around the object, get different snapshots of it, like they do here, and then render into that target. All your different like snapshots. Remember, this is kind of like you're gonna make a circle around this object. You know, move the camera here, and then the next one you'll move it here. And then here, however many you want to get, probably 8 will be good enough. So you'd get, you know, along the cardinal directions, and then probably, you know, these angles here. Put that in your texture, and then your texture is ready to go. And then you don't only need to do that once in the beginning, and you could probably even save that. Like if you didn't want to do that every time you loaded this component, then you could just save that texture like you would have some kind of step that you do. You know, this is almost like a what they do in all those systems programming stuff is you have your like build, and this is what you would do. You know, at build time or something, you'd create your texture at build time, and then that's like a static asset ready to go. You can imagine, like, once you have that texture ready, well, now you can just save it to a PNG or something, and then you can, you know, take out all this code related to rendering to that render target, and you can just load that PNG like a normal texture. So that might be worth doing. And then, in that case, right, it'd be a lot less work to do. Yeah, and if you were to build it like that, it doesn't really matter. Well, that's really weird because you'd be doing almost like client-side stuff in your build step. I mean, you could probably do all this without actually having to have a DOM and all that. You could use like an off-screen canvas. Should be able to render to an off-screen canvas. So it'd be like making images on the server, whatever, but using three.js. That would be really weird, but I could see it being possible. I don't know if three.js accesses like window properties and stuff like this, but I wonder if all that stuff could be like stubbed out like they do in Node.js, where like if you're running this on the server or whatever, there's not a window on the server, but you just say that it's undefined and you have to check for it and stuff like that. I don't know of anybody that's using three.js in that way to create images. But it should be possible, assuming that like everything's been set up in that way. So that'll be interesting if we get there. I don't know if I want to deal with that or just call it good like this. Like just do everything at runtime. I mean, we'll see how it goes once we get closer to that being a real thing. But yeah, if you did have that, so at this point, there's no difference between loading the texture that you've created at build time or creating the render target texture at runtime. They're going to have the same information in that texture. Once you have that ready to go, then it's going to be the same thing that we currently have on the website, where you have something like this, and then this is the logic that I haven't explained yet. But what it's doing is taking the angle of it's taking the dot product, no, sorry, the cross product of the camera's position with the sprite's position, and using that as finding that angle, then using that as a index into your texture, and you're setting the texture offset to match that index. So that's kind of like the math involved here. Is which of these sprites do I need to show? Well, it matters what the angle is that the sprite is. Is it facing the camera? Well, it's always facing the camera, but are we looking at the back of the sprite? Or the entity or whatever, right? And I can explain that in more detail probably next stream. It is pretty simple. This is a two-dimensional cross product, but it will tell you, you're gonna get out either a positive. You really only care if it's positive or negative. And then the angle here, yeah, there's like three.js stuff that will tell you these are vectors, these positions are vectors, so you can just get the angle out here. A position is really just a vector from the origin to wherever that position is in 3D space or 2D space or whatever. It's just a vector from the origin. So you can do vector operations with these things. Yeah. That will be next stream, probably Saturday? No. What's today, Tuesday? Tuesday, so I think next stream will be Saturday. Wednesday, Thursday, Friday. Yeah, I think it'll be Saturday. And next stream will... right now we're only showing one snapshot, but what we'll do next stream is get the other snapshots, put them on the texture, and then show the right sprite depending on the angle that the sprite is and the camera is, right? Whatever that angle is, whatever sprite we need to show. So that sounds pretty easy. And then if there's time or I feel like it, then we'll talk about how we can maybe do this stuff at build time. Or, do you want to do it at build time, or do you just want like a script or something that you run anytime you swap out this texture, or anytime that you swap out the scene with something else and you need to recreate that texture, and that's a static thing, you can do that. You can write a script for doing that. That might be the approach. Yeah. So I don't know if there's anything else to explain. I think that's a good direction to take. And we're at 2 hours, so I'm gonna go get some lunch, and I don't know what I'm gonna do for the day. I'll probably go for a walk or something if it's not too hot. I feel like I need to call my dad too. I haven't called him in like a month or something, so I was planning on doing that sometime this week. So tune in next time on Saturday if you are so inclined. Thanks for watching, and we'll see you Saturday. Bye.